Testing. Can I start? Yeah. So, I guess we only got the hardcore IRC weenies here today, huh? Yeah. Yes. So a little bit about me. I'm a independent security consultant. I do web app testing and network stuff, code review, incident response, a little bit everything. Went to the University of Delaware. At the time, they didn't really have any security courses, so I was studying like ancient philosophy, like Plato and Aristotle and stuff. Um, Back in 2007, I won Sensic Sans contest. My homepage URL is right there. I'm on Twitter. That's my email. I'm a ham radio operator. I'm in the software-defined radio, and I'm into writing automated attack tools. So I just wanted to talk a little bit about the history of IRC vulnerabilities, attacks, that sort of thing. Before Sean Fanning wrote Napster, people were trading a lot of wares on IRC, so DCC was the big thing. And the TCP stacks back then were such that if you set a 0 in the source port field, which would be equal to the IN ADDR any, it would just pick a sequential port. It would be the last one it bound to. So it's really easy to basically hijack somebody's O-day when they were sending it to someone else. Yeah, so there was a variety of things that came out after the original DCC. There was XDC, egg drop bots. MIRC had this CTCP command called fserve. And just in case you guys didn't know, DCC stands for Direct Client Connection, and CTCP is client-to-client protocol. Okay, so these are some of the techniques that people would use to get others' IP addresses. They would paste a link and then check the access log because they knew that no one else had accessed that page. So another thing was they would look around for like different DNS records that, if they existed, then, perhaps that could have been the person's IP. And that was one of the first things I tried it because if you've ever seen a cloak at the beginning, it has the hash, and then at the end, it actually has the address. So I would try scanning out the subdomains. This was interesting. Craigslist used to allow you to upload image tags, and it only allowed them if they weren't in the .com domain. I guess they assumed that if they could prevent spam, then they could prevent any type of attack. But recently, what they did was they made this service called Craigslist Image Upload, which is what you see highlighted here. So good job, Craigslist. Okay, this is how addresses get cloaked. If there's a successful reverse lookup, then you'll get the DNS host name and you'll get the cloak at the beginning. So this one at the top here, that's the Linode address. that first part is the cloak and the rest is the address, obviously. But what may not be so obvious is the second part here. That's a numeric IP address that's been cloaked. One of the things that you want to do if you're going to uncloak somebody's address is you want to know what kind of cloaking is in use. And one of the ways you can do that is you can run the raw IRC module command. So you can see at the bottom there that they're using MD5. A lot of places do use MD5. However, I have seen on other networks, SHA-1, Ripe MD160, and others, that slash quote command right there, that's not available on all clients. Sometimes it has to be slash raw. Sometimes you can type it directly. Okay, so there's more than one way to cloak your address. One is the IRC server is going to do it automatically. And what they'll do is they'll set your user mode to +X, or if you've seen, like, on usually when you automatically connect, they'll make you invisible so nobody can run a who command on you. So they'll set you +I. So it's the same idea right here. Another way they can do it is they can request a virtual host from HostServe, and then the IRC operator has to approve it. I tried to request a virtual host that was the same host name as the NICServe, but the IRC operator rejected that, so that didn't work out. And another, there's a couple commands that you can use to do it as well, like change user, change ident. And what we're looking at here is, this is the code for Unreal IRCD to hide a cloaked host. So this these underlined pieces of code here, that's where it's concatenating piece of the real address with the piece of the cloak, which you can see in this IRC sprint F, where it's got the %S and the dash. And this is also a cloaking function, but the difference here is that it's a numeric IP address, meaning you couldn't resolve the reverse DNS. So what it's doing is it's using a slightly different algorithm. It's using some keys, so it doesn't always end up being the same value. At least not the same value on other IRC servers. Wink, wink. Okay, so this is just a basic way that you can decloak yourself. If you remove the umode -X, you can see here that at the top it's cloaked because you can see the hashes there. And then the second one actually has a IPv4 address. And the reason that's internal was because I was, testing on my PC. And then I re-enabled it there, and it shows the cloak again. That 378 numeric, where it says is connecting from 192.168.1.6, the only people that can see that are yourself and the IRC operators. That's just for convenience. Nobody else can see it. Everybody else is just going to see the cloaked address. Yeah, like I was saying, it's not always going to be MD5, and this is on one of the anonymous groups IRC servers, I believe. and it's showing in that numeric 351, and it's the underline, like the third one down. It says ENC underscore SHA-1. That means they're using SHA-1 to cloak their addresses. And another big difference you'll notice in the cloak here is that it's not hex. It's just strictly alphanumeric. And then, like I was saying, you can request vhosts. There's a channel on the list right there dedicated to it. Okay, what we have here are some keys for IRCD 7. We've been talking about Unreal IRCD thus far. IRCD 7 uses a different process when cloaking. These are 3 different cloaking modules that I grabbed. That key is supposed to change, because if it doesn't, what happens is you'll have people that have the same address, they'll have the same cloaked address on other IRC networks because they're using the same key to run through the hash function. And when I was searching around online, all of the IRC daemon configuration files that I ran into had this static because they didn't force you to change it, unlike Unreal, where it will not even run after you install it unless you generate cloak keys. So I think that's a problem. So yeah, here's an example of the cloak keys for Unreal IRCD. Basically, you've got to have the same cloak keys on every single IRC server. Otherwise, what happens is you end up with clients that have different cloaked addresses on different IRC servers, and then things get confusing, because if you try to ignore somebody, for example, you're going to be ignoring a cloaked address that isn't the same on another server. So okay, you've ignored them on the current server, but you haven't ignored them anywhere else. That's no good. Okay, this is probably the simplest cryptanalysis and simplest attack that you can run against cloak IP addresses. You don't need any special tools. You just need a pair of eyes to be able to look at the cloak. And what you do is, if you who was somebody, as you can see right here, this fellow is using the same IP address because he has the same cloak. And at the top there, we know that he's using a different address because he has a different cloak. And it's not just with one user. You can use this against multiple users, meaning that if you see another user with the same cloak as somebody else, that means they're using the same address. Okay, to get MD5 seed values, there's a couple different commands you can use. I've got them listed here. Basically what this is what the MD5 algorithm got seeded with. So if you know what it got seeded with, then you can more or less predict what it's going to generate in the future. So the birth date there at the top, I mean, that's basically just the stro F time of the 32-bit Unix timestamp. And yeah, it was like I was saying. Yeah, so the server uptime is also there. There's the birth date again. Oh, and yeah, it also depends on if you're going to go that route and try to crack the encryption, it's also going to depend on how synchronized the other servers on the network, their time is like with each other. Because if you have a second or two off, then it's going to throw the whole cracking off. So that's how you do it, right? Everybody agree? No, that's not it. Not it. Honestly, that was the first thing I tried. First route I tried. I don't doubt that it could work. I think you could use rainbow tables to really make it work because any of the other plain text would look like gibberish instead of an IP address. But what we want to do is we want to find something that doesn't require the computing power that cracking encryption would be. And the other issue you're going to run into is hash collisions. So, what are we going to do now? I had to think long and hard about this one. Yeah, that guy freaks me out. So, what you do is you create a hideout channel and you set plus E, which is exception. That's so you don't get banned. And then you basically enumerate each of the octets. So right here, you can see it enumerating the first octet. And then when it unbans the target, you'll be able to tell which one of these band masks matches the user. And you always want to clear the bands through ChanServe. And the reason for that is if you try to do it yourself, then you're probably going to end up flooding yourself off because you're going to be sending so many mode commands. And if you ask ChanServe to unban somebody and they match one of these band masks, what's going to happen is that there's going to be either a service bot or a server that's going to mode hack the target. So if you see unban hack, then you know that you're matching their address. So you pretty much do this for all the octets, and it's going to be whatever, when they connected to the IRC server, whatever the get peer name was, that's the address that you're going to be going after. It's really noisy, but from what I can tell, there's nobody's noticed. So, but it gets better. So the reason this works is that IRC services are basically God of the entire IRC network. And I compare it to, UID 0, like root can sometimes get permission denied because it's not actually running as a driver in ring 0. Well, the services pretty much see everything in the clear. And this is why it works. If you follow the red arrows, say that wireless access point is the attacker. If you follow that red arrow, that's the attacker's IRC server. And then if you go over, that's the IRC services. So that's where NixServe and ChanServe and all that stuff runs. And then you keep it. That is going to ask the target's IRC server what their address is. And then it's going to go all the way back. So what was tested? We tested Atheme, Anope, and Anorostats, and these three are the most in use at the moment. And Denora is derived from anope to begin with, so they're pretty similar. Now there are some networks still out there that don't use cloaking at all, where you can just see their address if you whois them, and I have those listed here. So Undernet, FNet, 2600net, etc. So anope was forked from Ipana in 2003, if anybody's familiar with that. And then A-theme is what Freenode uses, and Freenode's the largest IRC network in existence. It overtook Eris Freenet, which really surprised me. The Stats is interesting because it has a web-based front end, and one thing I noticed was that if I whois somebody, I could see like 2 octets of their actual address, and then the rest would be a cloak. But if I went on their web-based front end, I could see 3 octets. So then I had it narrowed down to a /24. And this is why there's problems with IRC, because people just fork from each other over and over and over, and then somebody that forked from somebody else ends up, getting forked from again, and it's a clusterfuck, to be honest. So we want to do this stealthy. We don't want to get caught. We want people's IP addresses, but we don't want anybody to know that we have their IP address. So what we do is we set up a hideout. We register a nickname, and then we register a channel through ChanServe. Now, not all networks require you to register with ChanServe, and not all networks require you to reply to a NICServe email with a nonce or to click a link or whatever to be able to authenticate. Some do, some don't. I prefer to pick short channel names. That way you're not flooding yourself off every time you execute a command. And I also set all the security settings on ChanServe, like guard and protect and that sort of thing. That way, if like IRC ops join, they're gonna have a tough time shutting down my channel. So this is part of setting up the hideout. The bot serve is useful sometimes because you can say the exclamation point, the bang unban command right in the channel, instead of having to message ChanServe to unban the person. And yeah, this is another useful option. Don't kick ops. And then mlock and enforce. That way you can keep the channel keyed and secret and all that good stuff, and nobody's gonna find out. Another good little tidbit of information is once you connect, you'll get this this response in the middle here. You can also get it by running a version command. You want to know how many modes you can stack at one time. And in this case, it's 12. So this is one of the things that you're going to do after you've set the bands, and you want to check if any of them actually match a nickname. You're going to just run that bot command, and if it matches, then either the services server is going to hack the mode -B, or ChanServe is going to -B for you. And the other thing is, you always want to clear bands, like I said, because if you don't, either the band list is going to fill up or you're going to flood off. So here's a screenshot, and this is towards the end. That's the last octet right there. That's the actual IP address at the bottom. But the question is, can we do better? Can we do better than a linear search? So to optimize this, one of the things you can do is take the reserved addresses and cut them out. The only disadvantage of this is that you won't be able to match local users. So for example, an IRC operator, but most of the time you're not going to see people on IRC coming on from a multicast address or something like that. At least I've never seen it, but I have seen 192.168 and 127. Okay, so these are some alternative ways. I've seen IP addresses published in logs. Say that a client removed umode plus X. Now, what happens now is you can run a who was on them, and you will see the instance of their cloaked client, but you'll also see an instance of their uncloaked client. Even though they happen to be cloaked at the time, it's still in the who is history, which is really helpful. Yeah, PHP to Nora, any kind of stats script. We'll display IP addresses occasionally. Yeah, just people making silly mistakes and pasting their IP address. Yeah, keep in mind that IRC operators can always see your address no matter what. Yeah, scripts and bots can spill the beans too, so you got to be careful about that. So this is how we really do it. The previous two techniques are kind of a joke. What you do is you use slider blocks, because nowadays you can include slider block notation in band masks, which allows us to match a lot more address range, like a larger address range than you originally would have been able to. And since this works against Charbidus, it also works against Freenode, which is the biggest IRC network out there. And so after you have you only need four band masks to accomplish this, sometimes even less. And then to check if any of those match, what you do, this CS command here, that's shorthand for private message chan serve, but it actually works on the IRC server. So if you do quote CS, it's going to private message chan serve. Same thing with quote NS. And yeah, by the way, patching AKIC isn't going to fix anything. There's multiple attack vectors on this. And if they do patch AKIC, then I'm just going to re-release another exploit with a different attack vector. So don't try it. You're just making things hard on yourself. So this is why binary search is so much faster. The result can be anything under that red line, that sideways parabolic curve. And the N is what we were doing before with ANOPE when we were enumerating the addresses. Does everybody understand binary search? So just in case, it's basically like if somebody ask you to choose a random number between 1 and 10, and you chose 50 because that's the most efficient way to do it. And then you just do that on and on and on until you reach the target number. And yes, this does work against Tor. It works against IPv6. And to decloak an IPv6 address doesn't really take that much longer using binary search, because the log of 128 bits isn't that much different from the log of 32 bits. If they're using Tor, then what's going to happen is you're going to uncloak their .onion address, which, yes, is not the real IP address, but at least you have a unique identifier on that client and something that goes back in the direction of their route. So these are a couple of the exploitable IRC networks. We already mentioned Freenode. It's got about 75,000 users annually, or I mean daily. Ryzen's another one. It's the number 5 largest IRC network. AnonOps, that's what the anonymous hacking group uses. Mozilla IRC, Indie Media, Swift, all those. These are some of the most popular vulnerable ones. I haven't done an exhaustive search to see, because there's like so many IRC networks out there nowadays that it's difficult to tell like exactly which ones are vulnerable and which ones aren't. Here's some less popular ones that are also vulnerable: Obsidian, Phonetic, Solid IRC, Dark Mist, Dark Sin. I tested these by hand. Okay, this is the really funny part. This was already patched back in 2008. I actually discovered it independently, but then I discovered this later. If you see this highlighted text at the bottom, it says fix unban command exploit that could be used to reveal the real host name. Now, the problem with that is that Ipana is what ANOPE was forked from, but ANOPE was forked from Ipana back in 2003. This is 2008. Even if it was forked after 2008, it doesn't matter, because this is an architectural problem. It's a problem with the IRC protocol itself. Fixing unban isn't going to fix anything. Fixing AKIC isn't going to fix anything. There's other attack vectors. There's so many attack vectors that it's mind-boggling. Okay, so now we're going to do a demo, if I can figure this out. Sorry, guys. I gotta open this in another video player. Sorry, guys. Yeah, here we go. This is going to be using the binary search technique. And what you can see at the top is the cider block is counting up. And I actually knocked this one out even before we got to /32. Yeah, you'll notice once we get down in the high 20s, I think it's 28, it already has the IP address. Yeah, look, .16, it already has it. Already has it before it even got to /32. Yeah, I don't know who Blacktip is. It was just somebody that was hanging out in DerbyCon on Freenode. Sorry, guy. I mean, I had to prove to people that this was working somehow. So back to the presentation. I wonder what this next slide is. Oh, who's that? I think that's everybody from DerbyCon's IP address. It's as of Thursday, September 19th, anyway. The ones at the bottom, they had DNS issues. So Power Cycle, they use the example.com isn't the real address, but that's actually pretty crafty. Got a couple of line node addresses there, but it's mostly residential Roadrunner, Comcast, Verizon, Fios type of thing. I couldn't resist using that one. Okay, so now we've got the address. Now what do we do? You can do some reconnaissance on the address. You can check blacklist, which is what I do. I'll check Squid's U.S. government blacklist. I'll check malware blacklists. I'll check for foreign top-level domains. I'll check for known spammers and that kind of thing. So yeah, you can use this for good or bad. You could use it on the defense side or the offense side. Could help you get a free botnet. So the botnet implications of this are that you're going to be able to report if you're on the blue team, you can report to the provider and thereby the user that they're compromised. So, and also, this is a hell of a lot faster than waiting for a subpoena because it only takes like 2 minutes to do. And then if you're on the red team, you can take advantage of it, use the existing rootkits, install a rootkit of your own, basically anything you want to do. These two sites I have here are pretty interesting. They're about botnet investigations. So we're going to be running a contest to see who can find the most interesting uncloaked IP address on IRC. It's going to be running next week. and the deadline is going to be October 6th at 5. If somebody patches something, don't worry, I'm going to re-release the exploit with a new attack vector. There's going to be exploits for multiple IRC daemons. We're going to have Unreal IRCD. We're going to have IRCD7 for Freenode. We're going to have ANOPE services and A-theme IRC services. The only piece of code that I really didn't test was undernet because they didn't click their addresses anyway. So this is a site where you can get updates on the contest, and the prizes are going to be a vintage box set of SCO Unixware. Well, actually, it's not SCO. It's so old. It was before SCO bought them out. So it's actually Univel, which was a joint venture between Novell and somebody else. Anyway, I don't know. It was a long time ago. Yeah, USL, whatever that stands for. And then it became the SCO group. These two URLs right here are very useful, irc.netsplit.de and alien.net.au/irc. Those are really, really useful. Netsplit.de was how I discovered, like, which networks were the biggest, which had the most channels, what they were running, whether they used SSL or not, that type of thing. So, if anybody's interested in this, check out the webpage. We've got a mint condition copy of TCP/IP Illustrated that we're giving away. The winner will get a choice of whether they want the Unixware or TCP/IP Illustrated. And I'll be mailing it myself via snail mail. So, workarounds. vhost is not going to work. There's a couple different kinds of vhosts. You can have a vhost in ircd.conf. You can have a vhost command. You can have hostserv. None of those work because the IRC server has to know your real IP address. Otherwise, it can't K-line you. Like if they wanted to ban you from the server, then they've got to know your IP address to be able to ban you. So that's why I was saying this is an architectural problem. I believe it's going to take a while to patch because they're going to have to go against the RFC to fix it, or they're going to have to write a new RFC. And then there's just so many different software packages out there already that are vulnerable that it's just going to be a nightmare. So this workaround at the bottom that says set never op on, that will actually work to a limited degree. And the reason is that if there's no operators, then there's nobody to set channel modes, which means you can't set an exception with a C mode plus E. You can't ban anybody. You can't unban anybody. You can't do anything. So that's a pretty decent fix. I mean, it's better than using an IRC daemon that just puts your IP address out in the clear anyway. So countermeasures, use proxies. So there's lots of different proxies out there. I've listed them here. I'm sure you guys know about BNC, VPNs, SSH port forwarding. Now, has anybody here ever used Mibit? It's a web-based chat client. Nobody's used Mibit? Nobody? Don't worry, it's not vulnerable. You have? Did I get one? Just one. Okay. Two. Yeah, I use it myself actually. And the reason being is that when you can launch it without registering, and reason number two is if you're connecting to an Unreal IRCD server, you can use this quote set name command, because usually what it'll do is it'll put your IP address in the geckos field, like the real name field or whatever it's called, and you can change that. So it's pretty good if you don't want to disclose your own IP address. But yeah, I would say the best solution to this is to just bounce through as many proxies as you can. If you're a ham radio operator, you can use packet radio BBSs as open telnet proxies. They have their own class A. So I'm sure you guys know how to use a proxy, right? Okay, shout outs go to Dylan Webb. He was a big part of this, helped me out a lot. It was his idea for the contest. It was his idea to come to DerbyCon. He, gave me a lot of great ideas. So stand up, Dylan. Stand up, Dylan. That's Dylan right there. He helped me out a lot. Thanks, Dylan. Couldn't have done it without you. Also want to thank David Klein. He helped me beta test one of the original proof of concept exploits. Hal Brodigan is the fellow who writes Ruby Ronin, if you're familiar with that. I had a lot of questions when I was writing the Ruby exploit, and he's just phenomenal at answering Ruby questions. John Tan from Loft Heavy Industries and Hacker News Network, which is now defunct. That guy has so many good old stories. Needs to write a book. And then Shane McCauley is a good friend of mine, good exploit developer. He's awesome. And any questions or comments? Feel free. No questions?